Another thing we can do with AHEM is image eye charts or any type of image through the eye model. So we're going to look at how to do that. We're going to look at a perfect eye model, and then we're going to put some aberrations on the eye and look at that, and then we'll correct some of those aberrations and look at an eye chart through the correction. So I'm going to start my eye model, and this time I'm going to load a saved file. So I'm going to click option 2, and that's my file name. Click OK. I'm just going to click default because I'm working with the settings file now. So now I have a few different things set up from our defaults. We're still using the AZ model. There's no correction on this eye. So now I'm selecting an object target type instead of a source. So I've got that box checked, and I'm using a lot of rays because I don't want to generate a clean image. And I've got eye chart and eye chart selected, number 2. And I've got a scale of 1, and I've rotated the target so that our eye chart is right side up when we look at it. I've got a larger retinal image window than I want to look at, so it's 3 by 3 millimeters. And then I've increased my display pixels a little bit to 511. I'm going to do one adjacent averaging. Since I've got so many rays in my system now, I don't need to plot so many of them on the graphics, so I set that to 1. So click OK, and then there's my standard setup for the Arizona eye model. I'm not going to change anything. I'm going to click OK. The ray trace is completed, which took a few minutes, and these are our graphic results. We're looking at a long view of our target and our eye, which our eye is very small in this case, so we're going to zoom in. You can see that there's our eye. Now our isometric plots and cross-section don't make a lot of sense because we're cross-sectioning through an eye chart, so those are the profiles of the letters themselves. However, when we look at the display graphic, we get an eye chart. So this is through our perfect eye. So the next thing I'm going to do is load settings for an eye that has aberrations on it. All right, now I'm going to reload my settings for my aberrated eye. That's the name of my aberrated eye with astigmatism. So now many things look the same until I get to the next screen, or next couple of screens. And now I have a Zernike coefficient input window. So I've got some defocus and some oblique astigmatism placed on the corneal surface. I click OK. All right, our ray trace has completed. And now we're looking at our eye chart again, and we can see that the astigmatism that I put on the eye model is evident in the eye chart. So here is our perfect eye. And here is our astigmatic eye chart. So now I want to correct that. All right, now I am reloading the settings for my corrected eye, which I corrected using optimization. So I'm going to start my model. And I'm going to paste in the name. Okay. Okay, so here's my first splash screen. Not much has changed except now I'm going to do correction. So I've got a spectacle correction that I acquired. So I click OK. And my second screen, not much has changed here. Here's my Zernike deformation that's still on my cornea. Click OK. But now I get another input screen which asks me for spectacle correction data. So here's my sphere correction, my cylinder correction, and my axis correction. And then I've got vertex distance and some description about the size of the spectacle that I have on my eye. So I've got some semi-height and thickness to the lens, and then some width and roundness factors. So click OK. Alright, so the ray trace has completed, and now we're looking at a graphic where the corrective lens has been inserted for me into the eye since I specified it. And the eye chart is transferring through into the eye. And then we can look at that graphic in the display. And this is the corrected image. It's not quite as good as the perfect image because it's only a second order correction in quarter diopter increments, but it's much better than the aberrated eye. So we can correct that further if we want to, but this is just a basic sphere and diopter correction here. So what we've done here is shown AHEM can trace any type of image target through the system, and we can add spectacle correction to that image.